Hey everyone, welcome back. Today, we are diving into a classic chemistry experiment, one you might have heard of. It's often called the sulfuric revelation. And believe me, it lives up to the name. We're going to unlock a pretty wild, hidden secret using one of the most famous acids out there. So what actually happens when you take one of chemistry's biggest bullies, a super powerful acid, and you pit it against something you probably have in your kitchen right now? I'm talking about sugar. The answer, well, it's not just interesting for the science nerds among us. It is genuinely dramatic. It's visually stunning. You just have to see it. All right, let's introduce the two contenders in this, let's call it a chemical showdown. On one side, we've got something you know very well, and on the other, something that frankly demands a whole lot of respect. And here they are. In one corner, you've got sucrose, C12H22O11. You know it as common table sugar. It's a carbohydrate, totally harmless, packed with carbon. But in the other corner, we've got the industrial powerhouse, sulfuric acid, H2SO4. This stuff is a strong, corrosive acid, and this is key, it's an incredibly aggressive dehydrating agent. Yeah, you can already tell this is not going to be a gentle little mix, right? Okay, and I have to stop right here and be absolutely crystal clear about this. This reaction is extremely dangerous. I'm not kidding. Concentrated sulfuric acid is no joke. It's highly corrosive and will cause severe burns. This demo should only ever be done by professionals who know what they're doing in a proper lab. So please, for real, do not even think about trying this at home. All right, with that very important warning out of the way, let's get to the main event. Let's see the carbon eruption. This is the moment we've been waiting for, when these two finally meet. So you pour this clear, kind of oily acid onto the white sugar, and for a second, nothing. It just sits there. But then it starts. The mixture turns this bright yellow, then a rich brown, almost like you're making caramel. But it doesn't stop there. It gets darker and darker until it's this deep, inky black. And that's when the real show begins. This black mass starts to swell. You see smoke coming off it, and it's getting ready for the grand finale. A huge eruption of steam-powered carbon. I mean, the peak of this reaction is just stunning. The black stuff doesn't just bubble up a bit. No, it grows. It actively pushes itself up and out of the container. It really does look like a giant, dark snake just rising up. It's a column of pure carbon, and it's one of those things that's just incredible, almost unbelievable to watch. So yeah, it's a spectacular transformation. But what's actually happening here? What's the secret? How does that black snake grow right out of simple sugar? Well, to figure that out, we've got to zoom way in, down to the molecular level. Let's break down the science. Okay, so the secret magic here really boils down to two things happening at the exact same time: dehydration and heat. Let's see how those two things team up to build that carbon snake right from the ground up. So sulfuric acid is what we call a super strong dehydrating agent. What does that even mean? Well, think of it this way. It has this incredibly powerful, almost desperate thirst for water. And it will aggressively rip water molecules, H2O, right out of any compound it comes across. Yeah, this quote is a perfect way to think about it. It's not a gentle process, not at all. The acid is like a chemical sponge that just violently sucks all the water out of the sugar. See, a sugar molecule is basically just carbon atoms with a bunch of water molecules stuck to them. So the acid comes along, sees that water, and just takes it. And it takes it with force. So you can really think about this reaction in two parts happening at once. First, you've got the what, which is carbonization. The acid rips away all the water, and what's left behind? Pretty much just pure black carbon. That's the snake itself. But then there's the why, as in, why does it grow so much? That's the exothermic expansion. Exothermic just means it releases a ton of heat. This intense heat instantly boils all that water that the acid just ripped out, turning it into steam. And here's the key. All that trapped steam has to go somewhere. It violently inflates the carbon from the inside out, making it all spongy and pushing it right up into the air. Now, this is way more than just a cool party trick for chemists. That same powerful dehydrating property, well, it has huge implications for our everyday world. Let's take a look at the real-world power of this acid. And get this, because this might actually surprise you. Sulfuric acid is the single most widely produced chemical on the entire globe. That's right. Number one. That one fact alone should tell you just how ridiculously important this stuff is to, well, pretty much everything in our modern world. So why number one? Well, because that same aggressive, water-grabbing nature makes it a true industrial workhorse. It's absolutely essential for making phosphate fertilizers, the stuff that helps grow the food that feeds billions of people. Think about that. It's also used in refining petroleum, pulling out impurities so we get the clean fuels we need for our cars and planes. And speaking of cars, it's the electrolyte in the lead-acid battery under your hood, the thing that gives you the spark to start your engine. Its power is literally everywhere. You know, this whole reaction is just such a brilliant reminder that there's this incredible, unseen power hidden inside the most common things around us. I mean, who knew all of that was locked away inside a simple bowl of sugar? It's just a complete chemical transformation, and it reveals the basic building blocks of matter in, well, the most dramatic way possible. So that leaves me with just one question for you guys. What chemical reaction should we break down next? Let me know. Thanks for tuning in, and as always, stay curious.